Let's talk about API S category as well as the ILSAC specs. These are similar to each other, but not exactly the same. So I'll clarify exactly the differences as we go along. Now, these different specifications, along with ASEA and JSO and everything else, they don't exist in a vacuum. They exist as part of our regulatory framework, let's call it. There are societal pressures, there are governmental pressures, there are all kinds of things which come to bear on these different categories. So to explain a little bit of context, if we kind of put a timeline to everything going back to the early 2000s, right, what you'll see is that a lot of the different oil, let's say, specifications, they kind of line up with each other. And one of the reasons for that is because they generally map onto emissions regulations. And so these kind of go in lockstep. It's one of the features of the lubricants industry that generally OEMs and equipment manufacturers, they bring technology to the market, and then the lubricants platform, if you like, is an enabler. So they then have to adapt to all the new technologies that the OEMs have brought into the market. And that's why a lot of the oil specifications tend to follow new technologies. So previously, everything was about emissions control. And if you look at the history of things like exhaust gas recirculation and diesel particulate filters, selective catalytic reduction, they all exist in this age where we were trying to control emissions that were coming out of the tailpipe. At some point, it got to the point where we had controlled emissions to the point where it was one of those laws of diminishing returns. We weren't really going to be able to reduce it much further. And the only real way to reduce emissions was to reduce CO2 that was coming out of the tailpipe. And the only effective way of doing that is to control fuel efficiency. Now, at the same time, you've got to take into consideration things like, changes in fuel consumption over time. And one thing that you can see here is that there are clear trends, right? There was a clear upswing in the 70s. That's probably associated with some of the oil shocks, right? So if there are high oil prices, then the manufacturers are incentivized to create very fuel-efficient vehicles. Then we have this flatlining throughout the 80s and the 90s and the early 2000s. Of course, early 2000s, we have a number of different phenomena coming to bear. So one of them was very high oil prices. So, crude oil got to about $140 a barrel in that sort of 2008, 2009 time period. And that's extremely expensive. So again, incentivizes manufacturers to make very fuel-efficient vehicles. But at the same time, we've seen the climate change movement really gain steam. And as a result, a lot of manufacturers are incentivized, whether by social pressure or by actual governments, to kind of intervene and produce vehicles that are overall achieve more miles to the gallon. Now, when we're talking about light-duty engine oils, the specific trend line that we want to monitor is this green one, which looks at cars and SUVs. But overall, what we can see is that we had that emissions control that was quite successful, and now we've moved into that fuel economy age. Unfortunately, as you try to make gains in the realm of fuel economy, often the oil pays for it, and so we've seen that with the S category at least, there have been numerous new tests introduced to ensure that engines can be protected even when they're getting thinner and thinner, because that's one of the predominant ways that you can make an oil fuel efficient. So with the SH category, for example, there was one new test. SJ, there was one new test. SL, there were 4 new tests. SM, another new test. SN, one more new test. When it came to SP, right, the industry really demanded like 7 new tests, and this was kind of unprecedented and was the reason why we needed the interim SN+. Right? You can see here that there's only one new test added to SN+, and this involved LSPI. We'll get onto that in a second. But with the SP category, there were a raft of new tests. Valve train wear, low temperature sludge, oxidation, fuel economy, LSPI, and chain wear. So that's why the SP category has taken so long to reach its maturity. Now, if you look and you map a lot of those tests onto, what do they actually give you? Well, it's better fuel economy, it's LSPI protection, chain wear protection, improved cleanliness, and better high temperature viscosity control. So we are demanding that light duty engine oils do more than they ever have had to in the past. Now let's briefly talk about LSPI, because this is a really important one. Now, LSPI is one of those unintended consequences of the manufacturers trying to do a good thing. So in an effort to make engines as economic as possible, one of the predominant things is that we have shrunk engine sizes, right? So, previously a 1.5 liter engine was quite absurd. Now they're pretty standard, right? 2 liter engines are probably the most common size in the market today. And just 10 years ago, that was considered a very small engine. One of the other things that we've done is we've added turbos to everything, predominantly to increase efficiency. Direct injection has become a lot more common. Things like stop-start systems, as much as they are an annoyance to consumers, they do help save quite a lot of fuel. Then we've obviously got the rise of hybrids, and of course, engine oil technology has to play a part. But when you put all these things together, we have the rise of this new phenomenon, which is called low-speed preignition. Effectively, it's a little bit like detonation or knocking, except that it happens before the spark ignites, right? As the name suggests, it's pre-ignition. And what you see is because the ignition occurs before top dead center, you actually get a flame front, which is moving out into the combustion chamber as the piston is still moving up, right? So we have a flame front which is moving in the opposite direction of the piston, and that's why it's so damaging, because it can cause these massive pressure spikes, and that can be very damaging to the engine. So again, that's an unintended consequence of all of these fuel economy technologies. And so the oil has had to adapt to that, and that's why we saw the new LSPI test as part of the SN Plus as well as SP category. Right? So better fuel economy, what does that mean for engine oils? Generally, it means lower viscosities. LSPI protection, and we'll get into this at another time, effectively means fewer calcium detergents and more magnesium-based detergents. It was found that calcium detergents are a likely contributor to the phenomenon of LSPI. Then we've got chain protection. Well, we need more ashless anti-wear for that. We can't just put more ZDDP into the system, because we then run into problems with the catalysts, right? So we have to use ashless anti-wear. Improved cleanliness means we're going to better solvency and improved detergents, and then better high temperature viscosity control, generally higher quality base stocks. And this general move and this sort of compression of base stock strategies towards more Group 2, Group 3 formulations is something that's been seen basically across the industry. So now we want to talk about the ILSAC GF6 requirements, because ILSAC GF6 is actually split into two. There's GF6A and GF6B. You might be wondering why that's the case. Well, GF6A is effectively a backward compatible specification. It covers all of the viscosity grades that already existed, from 0W20 right up to 10W30. Whereas GF6B is a new category that is a lower viscosity, a 0W16, or there's even a 0W8 out there. And of course, they never existed before, so it's not backward compatible. And you'll see that represented by a different symbol that would be on the packaging. But when you combine the two of these, what you get is the API SP category. Right? Now, there's probably a more general question about what is the difference between the S category as well as the ILSAC GF categories. Effectively, you can think of GF as being the S category plus some extra tests, which generally involve fuel economy. So if you look down to the year 2001 with SL, right? So we had an SL category from API, and then ILSAC came out with the GF3 category, which was the SL tests plus some additional tests around energy conservation, volatility deposits, viscosity performance, additive retention, and oil consumption. But generally, the one that they focus on is the energy conserving. So you can generally think of the ILSAC specifications as being the S category plus some energy conservation.